Hello, welcome back to the channel for another tutorial of supply chain analytics with Python. What if I told you that retail chains are losing thousands of dollars every day due to poor inventory management? This is why in this tutorial we are going to build together a Python simulation model to improve these inventory rules, with the objective of minimizing cost and maximizing the service level. For that, we are going to use 3 articles that I have published in my blog that are covering multiple methods, from the simpler one that are for the deterministic demand to the most advanced one for continuous and periodic review. To follow me, you just need your computer with a Python local environment, and then we can build together the solutions for the visualization, but also to find the best parameters for optimal rules. I will share the source code in a GitHub repository that you can find in the description of this video. Let's go. So before starting, maybe let me show you the type of deliverable that we are going to build together. So as I told you, the source of this analysis are 3 articles that I have published in my personal blog. You can find the link of the section in the description. So this section is covering everything related to inventory management, from demand forecasting to pure inventory management rules. And the first one starts with the deterministic demand. The idea here is based on the distribution of a demand. You need to find the optimal inventory management rules to minimize the overall inventory, which is usually linked to cost, but to ensure that you are meeting the demand. So in terms of outputs that we are going to build, first is all these different formulas that I'm going to define later, but also this type of visuals where you can visualize what the inventory management rule is doing. And then you can reuse the code that is available also in my GitHub repository to adapt that to different types of demand. And the objective here in this video is just to focus on the simple rules that are for inventory, for a demand that is deterministic. So we will try several concepts, and then at the end, I will test these rules with a demand that is a bit more stochastic to show you why we need more advanced rules for this type of demand. We are going to cover these rules in another video. Now that you have the context, we can start coding. If you want to use this video as this full extent, I would advise you to not look at the code yet and just set up a local environment in a specific folder. So this is what I did. And then we can start coding. What I did here is just copy and paste the README document that will show you what we are going to do for this tutorial. So as it is explained here, we are going to build inventory management rules for demand that is supposed to be deterministic. So maybe let me come back to the article so for you to understand what we are going to do. So for instance, here, this is a really good example. So what we mean by deterministic rule, we mean that it's stable. So it's every day at a store for a specific reference, you are selling the same amount of units. So this is what we are showing here. And what we want to do, what do we mean by inventory management rule, is based on the inventory on hand. So here, that's what we have in green. So the number of units that you have stored in the store. And what you can see is that the number of units is reduced, it's linearly reducing due to the fact that we have a constant demand per day. We want to know when we have to reorder. And this is here, like in blue, the different reorder points. And the idea here is to optimize the inventory level and avoid stockout. And what is stockout is when the inventory in hand is negative. So that means your demand is higher than your supply. And what we can see here is that the rule is quite optimal because we are never below 0. So what does that mean? Is like we are for sure we are covering the needs in terms of demand. Probably the inventory on hand could be lower, and this is what we are going to see in the different rules what we are going to implement. One of the deliverables is this visual. Why? Because what I want to do with you is to use this visual to understand the different rules. So we are going to build the function to create this visual. We are going to build the function to simulate the inventory based on a demand. So the inventory in hand, so like, let's say for instance, first day you have 50 units. If you sold 2 units the first day, then you have 48 at the end of the day. So this is what we see here in terms of decreasing inventory on hand. And we are going to build the mechanism also to simulate the replenishment. So every time that an order is created and replenishment arrives at the store, the inventory on hand is updated with the additional units. And then based on that, based on this core simulation tool, we are going to add some optimal rules and see the impact in terms of stockouts, average inventory, which is linked to cost. So let's do that. So now back to VS Code. What I will do is, so what I want to do is outsource part of the functions that are, I would say, pillars of the analysis in specific scripts with a class and modules inside to make sure that when we are building the solution, it's nearly ready for productization. So you can put that in a fast API microservice and then play with it in a web application. So for that, I will create a new folder and I will call that inventory. And in this folder, I am going to create inventory models. And in this model, I will use Pydantic to set the type of input parameters that we want to have. And here, this is very important because, for instance, if you follow the last video I did of this MCP agent that was using fast API microservice, this enables to make sure that the inputs that you have in the functions are following a certain schema. So for that, in inventory models, I will import from typing. I will import list and optional. I don't think we have list, just optional, and maybe literal. Let's see if we are going to use that. And then from Pydantic, base model and field. Yes, exactly. What you can see here is that Pydantic is in yellow because we haven't installed it here. So pip install Pydantic. Yeah. No, we don't have any conflict because I'm using a local environment, so we're good. So now we're good, and I will create a class inventory params, and I will put that as a base model. And here I will go back to the README document because here I have put all the different input parameters that I want to have in the model. So what we want to have is this annual demand. So what you saw in the visual is like 5.4 units per day or something in terms sold. Because what I did is took an annual demand and I divided by the number of days per year. And this will be like the average value that you will have in terms of sales per day. Then you have the T total. So it's the total time of simulation. So let's say like 30 days, 60 days, 90 days. So there will be the length of the visual that you will see. D-day, so here it will be the annual demand divided by the number of days that you have in the year. The cycle length in days. So this will be the number of days you have every time you replenish. So what you saw in the visuals is like in blue, you have the different orders. Between two orders, how many days you have. Then the order quantity. So every time that you are ordering, how much are you ordering? And this parameter will be, I would say, calculated by the inventory management rules that we are implementing. That will be based on the daily demand and on the cycle length. And then you have the lead time in days. So this lead time, and we'll see what would be the impact of the lead time. It's between the time that you create the order and the time that you receive it in your store, and then is updating the inventory in hand. You can put some lead time that would basically recreate the actual lead time of preparing the order in the warehouse and transporting the boxes or pallets to the stores. And then the initial IOH. So IOH is inventory on hand. So how much inventory you do have at the beginning of the simulation. So this will impact also by the inventory in hand that you will have along the simulation. So let's add that in the Pydantic class. So maybe in case we are using, or in case just for documentation, we can say the basic, we can put some information here. So this is the basic parameters for input. Yeah, I think it's good. So here, first we have D. So D here is the annual demand. In case, normally I could put integers, but here I will just put a float, just in case. And this is a field. I think it's good because we can put some description. In terms of default value, I will put 2000. The increment, I will put 0. And in terms of, like not decrement, like the minimum value, I will put 0. And in terms of description, yeah, the annual demand here, I'll put annual demand, units per year. Then it's not D, but it's T total. So here, it's going to be a float. No, an integer, because here we are talking about a number of days. So the default value, I'll put it 365. Here, in terms of minimum value, I will put 1. And in terms of description, I would say days in the simulation horizon. Okay. Then we have the lead time. And here, 5 days is a lot. Let's put default 0. Then we have, so let me just come back here. So we have the lead time, the cycle length. So here it's an integer. It's also a field, but here in terms of days, I would say 10 days. Review period, exactly. Or cycle. Yeah, we can call that review period or cycle time is the same. Then the order quantity. So it's a float. And here I would put, what did I put as a, yeah. It can be number of days multiplied by the, but that's the basic one. When it's more advanced, when you have lead times, it could be different. But anyhow, in terms of, yeah, here in default value, I would put 0. Or the quantity, here we don't have any issue. The initial IOH, so the initial inventory on hand. And here I have put 0. And yeah, I think we're good here. So we are covering this. So we have that. Let me maybe just create the Jupyter notebook. So Jupyter, create Jupyter notebook. Great. Here I will call it, so maybe let me save it first. I will call it inventory management. Great. But not in inventory, I will move it at the root. Yeah, move. Okay, so here, what I would like to do is first maybe import what is needed. So far, what we need is import inventory models. But for that, we should import it from inventory. Inventory models. I will import also a library called import lib. And here, this will be for debugging. Yeah. So if you're not familiar with that library, the idea here is that every time that we are running this block, we are re-importing the content of inventory models. And the idea is if we are doing some changes in the script, in this file, then it's impacted here in the Jupyter notebook. I think I will just import warnings also. I don't want to have like a message. Yeah, okay, I think it's good. So the Python environment, I will take the local one. I will install. So as you can see here, everything is new, like it's a new folder. So while waiting for that, so now that we have the models, what we can start is maybe to put the parameters that we have. So let's start with day. So the total demand here. Yearly. D will be equal to 2000. Then the total simulation time. Yes, in days, 365, great. The demand per day. And here we call that D day equals D divided by T, yeah. And then I think if I check I can check the README here, the cycle time. So we can call that the replenishment period in days. And here I will put 10 days. And in addition to that, now, so if we go back to the article, the economic order quantity will depend on multiple parameters. So it depends on, so the idea of the economic order quantity is to find the optimal order quantity to minimize the cost. And here what we are talking about the cost is the holding costs. So every time that you have an unit that is stored in the store or in the warehouse for one day, you have like a cost per day. Plus you have a cost every time that you are ordering the product for the replenishment. And you have a cost for potential shortage. So these are all the different parameters. And what I'm going to do is I'm going just to copy and paste all of them. Okay. Okay, and then we are here. So I'll go back here and I will copy and paste. So we have these parameters. Okay. Great. So now we have everything. So now that we have the input parameters, we can start building the functions that are needed to do the analysis. So for that, we go to inventory analysis. And here we are going to create the functions to generate. Let me go back. To generate these visuals. And the idea here is behind these visuals, we have this mechanism, as I told you, of management of the inventory on hand. So based on the initial inventory on hand, which is a parameter that I showed you before, we have this value that is decreasing along the days due to the daily demand. This value can be offset when we are reordering the same day if we don't have lead time or another day later. So all these mechanisms, we need to put it in place, and we need to create this visual so we are able to visualize it. So that's what I'm going to do. So back to the code. So I want to do that. I want to have a separate block for this. And for this block, what we're going to need is to work with data frames. So we will need pandas. So pip install pandas. And here we are going to import pandas. We're going to need the models, and from these models we need inventory panels. I called it that way. Yes, great. I think that's all from probably we need also some typing. I will just import optional. So usually I import them before using them. So, and here I don't think we need them actually. Okay, boom, we good. Okay, for typing, probably what we need is NumPy. Import NumPy as MP. So now we are ready to build our class. So I will define it. Class, not inventory analysis. I will call it inventory simulation. Okay, we can define the names. Okay, except for the inits, everything can be thrown in the trash. Okay, so first maybe, so what type of parameters we need to take? Well, the annual demand, the total simulation time, the lead time, the cycle time, so the time between two replenishment, the order quantity, the initial inventory on hand, and this daily demand is not important. It's not, because the daily demand is here, is self.d. No, wait a second. No, the daily demand here, daily, yeah, and I will call that self.dday equals self.d divided by, no, here we put the simulation time. Because what we assume here is that D is the demand for the overall simulation time. T is the simulation time. Here we will have the unit, I mean the time per simulation unit, and here we take day as a simulation unit. As I told you, so we are going to use pandas because we are going to use data frame for this. Oh yeah, cool. So you already got this. I will call that sim and is PD data frame. And here, what we need to for pandas is PD. Oh, I forgot that. And here we are going to initialize just so in the data frame you will have the time. Then second column would be the daily demand. So time would be 1 to T, and here T will be 365 for most of the time. Then you will have a column for the daily demand that will use D-day. And then you have a column for the number of units that you have on hand, so inventory on hand, and then a column for what you order. And this column for what you order will depend on the inventory management rules that you are using, and this will impact the inventory on hand. So first, here, only information we have is the time, so that we can use that to initialize. So here, I will take time, and then I will use, this is where we are going to use NumPy, where I'm going to say np.array, and here it will be range. Yeah, I think that's the right value. T total, and that's probably going to be it. Yeah, then we don't need to initialize anything else. Okay, so now we're good. We have initialized everything. The second column will be the inventory on hand, but I will define it in another function. But for this, what we need now is functions that will impact the inventory on hand. This one, I will call it order. So def order, that will depend on the day we are today, that I will call T. Yeah, the day between two order replenishment, the order quantity that is defined also in the input, and also another parameter that I will call start day. So here, why we are doing that, if I go back to the article that I'm using as a reference, as you could see here, that we have an inventory on hand of 50 units. We have two approaches. What we can say is that the first day we start with 50 units, and then we don't order anything, and we wait a couple of days that we reach the minimum level to reorder. Or what we can do is say, okay, we have nothing, and the first day we order. So for these two scenarios, I mean potential scenarios, will be dictated by the parameter start day. So let me go back here and show you how it looks like. So here, simple ordering policy. Yes, exactly. So I think it starts to guess, like a copilot guessed what I wanted to do. So what we return? We return Q, so the ordering quantity, if so T is higher than start day. I agree with that. So that means we start to order, and we are now at a cycle. So T is saying that we are ordering every T days. So to define that, yes, it's exactly this formula. We look at T minus start day, and then we look at if it's a multiple of T. And if not, we return 0. And then we can define a simulation. So here, I will define multiple type of simulations. Multiples, like this first one will be like a kind of a simple simulation. I will call it simulation 1. Simulation 1. This simulation will only take the parameter self. And I told you that we have multiple parameters, and one of them is the lead time. And here, for instance, if you are ordering every 5 days, but you don't have lead time, I mean, you arrive at day 6, you will order, and your inventory on hand will be directly updated. Or what you can do is you can put some lead time. You say, okay, between the time I order, if I order day 6, I will receive the product day 8. What I want to show you here in this exercise is what is the impact of the lead time. So the first simulation, we are not going to consider the lead time. So if we put lead time, it will be not considered by the rule, and we will see what will be the impact on inventory on hand. So I would say simple fixed cycle ordering policy. Yeah, ordering policy simulation, not considering lead time. Exactly. So here, this is for the exercise. Probably later, what you are going to keep is only the later one. So what we need is our data frame. So simulation 1, and then we need the first column. I told you there are multiple columns. The column 1 is the daily demand. So sim1 of demand self.day, exactly. So here, every day you will have the same demand, which is d-day, which is basically the total demand divided by the number of days of simulation. And then we need, so orders placed here, Yeah, I think that's a good point. So the orders here will depend on t. So I will define t, and I will here make sure that t is an integer, because it's every day, t days. Q, the order quantity, could be a float. So here, just want to make sure that it's a float. And then, let's see, order is taking the time, and we apply the function exactly. So every day we are looking at the time, at the column time, which is our t here, and we are going to get the order quantity that will depend on time, on t, and on q. Here, as I told you, we may have some lead time. So the inventory on hand, the second column, that will depend on the order, and the initial inventory on hand will depend also on the lead time. So first maybe let me initialize it so you can follow IOH. So in that case here, the inventory on hand, maybe for like less complexity, I will define a function called, like a column called receipt. So when the order is here, it's when the order is created in the system and when the order is received. Sorry. So here I call that receipt. And this will depend on the lead time. But here, maybe to make sure that things go well, make sure that it's an integer here. And the shift would be, yes, great. So for instance, if we have 2 days of lead time, we're going to have like an order this day 6 that will be received after a shift of 2 days. It will be received day 8. And then based on this, so here it's not inventory on hand, is order received, considering lead time. Great. And now we can start to talk about the inventory on hand. And so here we are going to use a loop. It's probably not the most efficient one, but that's the best approach that I found to explain it in a clear way. So this loop will fix the value of the inventory on hand. And for that, I will use, to keep these values, I will use a list. So I will call that IOH. That would be a list that we initialize at the first value, which is the initial inventory on hand. And then what we are going to do, we are going to loop over the different rows of the data frame. So the first thing we do when we arrive at the day, we take the inventory on hand value and we reduce we subtract the daily demand. Let's say, for instance, today you sold 5 units. You had 10 units at the beginning of the day. Your inventory in hand drops to 5 units. So I would call that subtract demands and add receipt. So I will call that the new inventory on hand. That's a good idea. And for this, what we are going to take is the inventory on hand of yesterday. So the last one, minus the value of the demand of today. And here I will use lock. That will depend on the day t and on the column, and we take that from the column demand. Let me do that. I will only subtract the demand. I will add, received orders. Okay. And so what we do here is on top of this, we add what we have received at the end of the day. And then we keep record new hash up, and then we append that. So now we can apply the inventory on hand on this function. I think we're good. We can return sim1. So now we have enough components, blocks, to start to simulate in the Jupyter notebook. So let's do that. If I arrive here, I want to put some markdown. Wait a second, here, a markdown, and I will just say scenario 1. Great. So in the scenario 1, here the scenario 1, I would say what we want to do is no lead time, simple ordering policy. Okay, great. So I add some code. Why do I have that? Okay. So in terms of parameters, I think here daily demand. So the daily demand. So here we don't change the demand. Why I'm doing that? No. What we do here is now what we want to have is a lead time. LD1 equals 0. Ordering quantity in units, and here what we are going to do is we are going to only cover the demand between two different replenishment order. So Q1 would be D-day multiplied by T. So for instance, let's say that T is equal 5. That means between the time 2 times you order, you have 5 days. Lead time equals LD1 equals 0. That means every time you order, you receive the product. So the optimal approach is to say, okay, if I have no lead time, I will take the optimal quantity that I need, like the maximum quantity that I need between two order, like replenishment orders, and that would be the daily demand multiplied by the number of days. Okay, so input parameters. Let me call that parse1. Here, don't need to do that because I have imported normally. Ah, no. Okay. From. Great. Now we have. Don't need to define them here. I will define. Wait a second. And here, inventory params. Here. So let me check. In the article, yeah. So the first the total D1. What's how? I mean, here it's not D1, it's D-day. No, it's D. Or maybe I can call that D1, so that way it's cleaner. Okay, T total equals T total. So here, only put T total. Lead time 1. T is T, we didn't change anything. The order quantity equals Q1, and the initial inventory on hand, So here in that sense, what we can do is we can say initial inventory on hand in units would be Q1. No, sorry. Here, the initial inventory on hand, and I will call that 1, will be called here. Okay, let me check just T total equals T total. Is it T total? Yeah. T equals T. T total is not defined. Let me just go back here. T. Okay, yeah, we forgot. So it's T total here. I don't know what I'm doing. We're good now, at least to set up the parameters. Then we can build the simulation. Create simulation. Simulate 1 equals. Look now. I forgot to import. Sorry. So import inventory dot inventory analysis. Yes, and then yeah. What happened here? Analysis. Inventory cannot import inventory analysis from inventory. No, it's not analysis. Great. Don't know why I call that inventory simulation. Yeah, that depends on the parameters. Okay. Should be good. If I look at, yeah, it's called simulation 1, just to check the, donc, sim1 equals, no, it's not run simulation, it's simulation 1. And we can return sim1. T is not defined. That's a good point. Inventory analysis. Sales. Great. So here you will see the why I used import lib. Tada! But you could see that the error is different. So I have a T here. I have another T here. Do I have any other errors? No. And now I just reload. Great. So what do we have here? The time from 1 to 365 days with the average demand. Here, the time when we order. So let me see. And 20. Let's not forget that, you know what? Let's not forget that we said T equals 10 days, every 10 days. So normally, and we start day is the first day. So normally we should order the 10th day, the 11th, yeah. And you see here, that's quite interesting because we order the 10th day, we receive the 10th day, and the inventory on hand is incremented the same day. But now let me show you. I put some lead time, okay? We create the order the 11th day. Yeah, because we have the delta. So it's bit, so we don't start. We start from day 2. So day 1, we don't order. And then we have 10 days here between the first day and the day we order. So here we order day 11. We have 2 days lead time. So we receive that 2 days later. And the inventory on hand is offset that time. And you could see here, we reach nearly like a negative, but actually 0 inventory on hand. But you start to understand, I think it's here 0. You start to understand the logic, right? How the inventory simulation here is working. So every day the inventory on hand is offset due to the demand, but can be compensated by what we receive from the order based on the lead time. So let me go back to here. The problem here is that we are looking at that from a tabular perspective. So we'd better visualize this. So what I'm going to do is I'm going to create a plot. Create a plot. Plot to visualize. So for that, I create the figures with axes. Why we need axes? Because we're gonna have multiple plots. So here we have subplots. It's gonna be 3 with 1 column. So why 3? I can show you in the article. This initial one for the demand, then what we order, and then the inventory on hand. Okay, back here. I will set up a fixed size. And I think the fixed size is 12.8, if I remember well. And share x equals, we share the axis. Oh, I forgot. Pip install matplotlib. Import matplotlib.pyplot as plt. Great. Okay, I can go back here, plt subplot, and then we start to plot the demand. So for that, I will use pandas plot. Here, the demand is going to be, with the x-axis, it's going to be time. Day doesn't exist. The y-axis would be demand. And then, just to make sure that is the first axis, 0, color blue, not blue. Let me see. Red. Legend equals false, but I want a grid. Grid equals true. So now we have that. We can put a label. plt.show. How does it look like? Demand doesn't exist. How did it's not with a capital D. Great. So we have something that looks like good. Is there First I will put font size here equals 8. Okay. Let me see how it looks like with the others. So the others, so here, I can copy and paste. But here, I don't want a normal plot, I want a scatter plot. And not plot, not scatter. So here, just quickly, it's order, yeah, blue. Okay. Great. So it seems that we have something that looks like what we have then in my article. And then inventory on hand. For that, I will copy and paste this one. Here it's the third axis. It's not demand, it's inventory on hand. Units. It's indeed the inventory on hand. It's not the time. The axis is correct. The color is green. Yeah, the color is green. Okay. Now we have an issue. Indeed, because it's AOH. IOH. Oh, that's cool. That's cool. I just don't feel comfortable about the limits of the axis. So format X axis. No. If I do that, let me see. Dot set limit. Limit or limits? No. It's X limits. Perfect. Perfect. I think we are good. Perfect. Now, let me try something. I put some lead time. What happens? We reach negative inventory on hand. I don't put any lead time. We good. We get up. Okay. And maybe let me solve this, because what if y limit? I'll try something. Yes, great. I want it to start with 0. Great. So here, what we could see is that the minimum inventory on hand is higher than 0. Is it the case that we have here? No, here we reach 0. Because, great. Why? Because here we assume that we are receiving the product as soon as we are ordering it. If we put a lead time of 1 day, we assume that we receive it at the end of the day. So after the demand has been offset. Okay, so now we have the first version, I would say, of simple inventory on hand rule. Let me go back to the different scenarios. So here, lead time 1 is exactly what we are showing. Lead time 2. And here, if I put lead time in terms with 2 days, what happens? We have a negative inventory on hand. Keep timing, increase quantity. Compensate for the lead time by increasing the quantity. Indeed. So what happens here is that when we are ordering the quantity between 2 different orders. So what we call the cycle time. However, now the cycle time is 1 day higher due to the fact that we have a lead time. So what we can do in terms of scenario, okay, I will put all the scenarios here so it's clear. What we can do here, instead of only covering the time, the cycle time, we can add the lead time, and we remove one, because as you saw, when we have lead time at 1, we exactly reach the quantity, like the level where the inventory in hand is at 0. Let's see what happens. And we're not good. Why? That's a good question. And here, we build excess inventory. Yeah. Which means that when we have a lead time, we cannot, I would say, compensate it by only changing the quantity. We need to look at the inventory simulation and maybe improve the rule. So that's what we are going to do now. So the small test that we did by changing the quantity of the ordering quantity showed us that it doesn't depend. We cannot find the optimal solution by only changing the order quantity. What we have probably to do is to tweak, to improve the simulation model. So I want to create a simulation too that will consider the lead time. But what would be the change between simulation 1? It would be at this core tool of, that is the function that will consider when you are to reorder. So I will copy it, paste it. Sorry. I will create a version with lead time. I will add lead time as a parameter. And then what I want to do is now consider the lead time in the equation. So let's say that we have 2 days of lead time between the time you order and the time you receive the product. What we understood is that if we have only one day of delay, what we are going to do is to reach the optimal inventory on hand, like trend, which would be, we are going to reach 0 at the end of the day, which is not bad, right? But when we increase to 2 days, then we have like a negative inventory on hand. So what we could do is, if for instance we have 2 days of lead time, is to order 2 days minus 1 day in advance. And for that, we just need to do this change here by adding the lead time minus 1. And then I will do the exercise here to copy this function. It's probably not optimal. We should probably find a way with a parameter to select the other function, but here I want just to show it for the exercise. I mean, not simple, like this room considering. Yeah. For the rest, it should be good. But now it's going to be order lead time, because we are going to consider order lead time. And we need to add the lead time. So here, what I'm going to do, LD will be the integer version of the lead time. And here we don't need to define it again. So here, when we are going to create the order, we are going to consider by the rule that we want to order every cycle time plus the lead time. So I will re-import this. I will use no lead time. Yeah, I will use this code. I will create, so is it the scenario 4? Okay, great. This is scenario 4. I will add markdown, scenario 4, lead time, ordering function compensating lead time. So I take the same parameters, call that D4. So yeah, here D4, the lead time will be the initial on hand, yeah. Okay. So now it's not simulation 4, it's simulation 2. And yeah, sim 4 here. So maybe no, we don't need that. Let me just see how sim 4 will look like. Let's just check if it's working. It's working, okay. Head 20. So what I can see is that it's not working. I'll go back here. Wait a second. 2 seconds. Is it a parenthesis issue? I'm checking the article just to make sure that I didn't take the wrong. Yes, that was a parenthesis issue. So what happened here? We reached day 10, right? So here before, if I'm fair, I want to show sim1 head 20 head. So here what happened is that, yeah, we start from day 1, from day 2. So we cannot order day 1. We wait 10 days, so we arrive at day 11. We create the order, but the order we receive 2 days later. This is why we reach a negative inventory on hand. And what we tried is to increase this quantity, but what we saw is that the inventory was increasing. Now, what we do is, instead of ordering day 11, we'd order day 10, so 1 day before. So that way, we receive the replenishment on time to avoid to have a negative inventory on hand. And if I show the result, it's not working. What happened? Now we good. Now we good. So the quantity was not good to that. So now we only order what we need between the demand that we need between two reordering. The cycle time, and we reach 0. So this is perfect. And why we do that is what I showed, is we are reordering 2 days before. So now we have a robust inventory management rule that we can simulate and visualize, and that can compensate lead times. So if I go back to my README, now we need to consider the economic order quantity, because if you remember, the optimal quantity, the quantity that we order here, we just depend on what we are consuming between two replenishments. It's probably not the optimal one. Maybe let me just set up an actual quantity here. Lead time 1. Yeah, that's the initial setup. So here, the quantity that I have set up here is just the demand between this point and this point. So what we are consuming here. Is it the optimal quantity? I don't know, because if you look at the average inventory, it's pretty high. It's like 25. Maybe we can reduce that, considering that our demand is quite stable. So for that, we are going to use the economic order quantity. So I think I will call that scenario 5, economic order quantity. And for this, to be honest, I will just use the formula that I have explained in the article. So I will take these different parameters. So here I will call that C5. So that's the cost of a purchase of a product, the cost of placing an order. So here, why? Because every time that you are ordering here, you are placing an order. So if you increase the time between two orders, you are reducing the number of orders placed, but you are probably increasing the average inventory. So you need to find the right balance. That's what the economic order quantity is doing. H5 here, I put 5s everywhere. So that's the holding cost. What cost of holding a specific unit per year cost, and the selling price, and the cost of shortage in case that we have shortage. So it costs 12 euros per unit. And then I will just take the formula that I have from the article. Lead time. Let's put 0, 1, like the optimal one. Oh, I need to import math. Sorry for that. Import math. Here I call that 5. Yeah, I called it 1 in the article, that's why. So what would be the economic order quantity here? 400 units per order. Okay, so way higher than the 50 that we are ordering here. But it means that replenishment cycle time in days. So here, T5 would be, so here it's not 1. I'm calling that 1. The article is called 1. Q5 divided by so D, it's like the total. So it's, let's say that we are simulating for a year, and you know that you are ordering for the year you have a demand of 2,000. If you are ordering 400, that means you have only 5 orders. So you take the demands, like the quantity per order, you divide by the total demand, and you multiply that by the time. the total time. So here it would be 400 divided by 2000, so it would be 1/5 multiplied by the total time. So T5 would be 73 days. And here it was 10 days only. So we will see the impact. The initial inventory on hand, let's say Q5, okay? So params 5, let's see if the autocomplete can. So yeah, the total demand is the same. So I call that D. T total is the same. Lead time is the same. I have put only 1 day. The time is what we calculate. The quantity is the economical. The quantity definition on hand, inventory on hand is the same. Okay, simulate 5. We simulate using, no, we use the optimal, or we can try with the first one. And yeah, the visual. And for that, yeah, I won't bother myself. Just copy and paste. It's far from being optimal because I will have to rename everything. My bad. But here I wanted to focus mainly on the formula and explaining the formula. Let's see what happens. So here, let's try with the initial one. Okay, with the initial one, we don't, yeah, because we only have 2 days of lead time. So first, as you could see here, I don't know how many replenishment we have. It's like hundreds, maybe. It's like not 100, maybe 20, 25. Here we only have 4. We only have 1 day lead time, so that's why we don't reach negative inventory on hand. But if I put 2 days, then we reach negative inventory on hand, and we don't see it here. So plt.show. It's because, yeah, because I have as you could see here. Now we're good. So I put 2 days, but we reach a negative inventory on hand. We don't see it here, but it's negative. Because if you check Sim 5, Sim 4 or Sim 5? Sim 5, iWash, it's negative. But we use the optimal one, yeah, we can consider that as 0. Okay, so here is the inventory, the economical order quantity applied to an inventory rule that is a bit more robust. And that's the NEC plus ultra, like the highest that you can reach with a deterministic demand. Is it robust? Yes, if you have a stable demand. What happens if you bring some stochasticity? This is what we are going to see just after, and that will finish the tutorial. So now, if we look at my README, the next exercise is to introduce some stochasticity. So the idea here is to understand what would happen if we use these supposedly robust inventory management rules with a demand that is not stable, that has a bit of volatility, like that is characterized by the standard deviation. So for that, first, maybe we are going to change the input parameters. We are going to add a new one that I will call sigma, which will be a float and the standard deviation of the daily demand. Yeah, exactly. Then here I will add sigma as parameter that we fetch from the params. Yes, great. And what I would like to do is to take a third simulation and here add sigma. And here, instead of having a stable demand, yes, I would take, so here, a normal distribution, that could be okay. That would depend, so here, yeah, the daily demands, I will take it d-day, self.d-day, so that way I don't have to recall d-day. A normal distribution of an average that would be d-day along the overall simulation period, t total, with a demand variability of standard deviation of sigma. So I will call that simulation 3. Let me see. I think it should be good. We haven't forget anything. Let me try. So, here I will upload, import everything that we needed with the updates that I just done. I will have mark down scenario 6 or 5, all right, 6. Normal distribution. I'm gonna take these parameters, so I will just replicate. Now I will add sigma, the standard deviation, a standard deviation of 20, which, let me check in the article how much I used 2.5. Just want to have the same, insights. Let me add it here. It's not sigma d, it's sigma. It should be good. Here, 3. Wow. That's not bad. We are lucky because we are using the economic order quantity. Let me add a bit more. Yeah, it's pretty low. Yeah, because the economic order quantity is 400. So why did I do that? Yeah, I remember. In the article, I took 2.5 on the initial example. So let me see. Let me redo it. So let me take this beautiful example instead. Okay, where is the sigma? Okay, I'll redo it again. Alright, sigma equals, and here I will just put it directly 2.5. Here I take simulation 3. Yeah, that's what I wanted to show you. So what happened before is that I took the economic order quantity where you have 400 in terms of units that you order every time. So a bit of the standard deviation was too low to have an impact. But here, every time we are ordering 50 units. So if I take a standard deviation of 2.5, it's like 5%. Yes, 5% of it. Just 5% of it, look at the impact. And this is why when we have a stochastic demand, we need more advanced inventory management rules, and that will be the topic of the next tutorial. So if you have followed me up to here, thank you for that. If you have any question, feel free to use the comment section for that. I will share this code probably like in a more cleaner way in my GitHub repository, so you can launch it on your own, tweak it, and maybe productize it so you can use it in a dashboard or with an API. And see you for the next tutorial, probably the next version of it, but now with more advanced inventory management rules for stochastic demand.